Mic check 1 2. Mic check. Looking good, sounding good. All right, let's kick this into gear. Start recording. Boom, boom, boom. Alrighty. Welcome, party people. Welcome. Biochemistry Part 2. So if you watch the video format, this will be Part 2 of Biochemistry. We're going through Dr. Morse's Detox Miracle Source book. We went over quite a few things. Let me stop the music and let's do a brief recap, right? All right. So last time we spoke, last time we went through basically the beginning of this book and covered module 2.3, and today we'll be going through module 2.4 and potentially some more. So last time we went over absorption. We went over a lot of the different systems. I think we covered every system. The methods of how the body works, and some basic facts about the anatomical differences of different species and their different diets and the size of their organs and whatnot. So without further ado, let's go into module 2.4. We're going to be going into tissues. All right, let's zoom in. Let's make sure y'all can get a good view of this. There we go. All right, so module 2.4, tissues. Most of your individual cells are grouped together to form tissues. Then tissues can be grouped together to form organs and glands. There are 4 primary types of tissues that comprise, line, support, protect, or control the basic structures of your body. So types of tissues is epithelial. This covers the surface and the linings of the body's cavities or from glands. They're found in the digestive tract, lungs, blood vessels, etc. Connective, this type of tissue is supportive and holds all cells, organs, and glands together. We got muscular. These tissues support your skeletal structure and are used for movement of various structures, including your limbs. We got nervous. These tissues comprise your information highway, the nervous system. These tissues are highly charged and allow electrical transmissions to take place. Disease is not found in healthy tissue. So when tissues, organs, or glands fail to do their job, this sets up a domino effect throughout your body, causing many different disease symptoms. Vibrant health is equal tissue regeneration, alkalization, detoxification, nutrition, energy equals vibrant health. So this all ties into the fruit diet, where like fruit is super alkaline, and it'll help you detoxify because it's also very liquid dense, very hydrating. Remember, all your tissues are made up of individual cells, each requiring nutrition, energy, and proper elimination. So that ties into the first video, module 2.3 on the cells, where it tells you about the mitochondria, its own metabolism, and how to keep it healthy. Now let's examine the tissues called organs and glands. So this would be really interesting. The cardiovascular system and blood. Let's go into module 2.5 right here. Alrighty, your heart is a 4-chamber holding and receiving organ with a system of valves that allow blood in and out. You have 2 chambers on the right and 2 chambers on the left. The upper chambers are called atrials, and the lower, larger chambers are called ventricles. Sorry, I can't talk today, apparently. Fresh oxygenated blood comes from the pulmonary arteries into the left atrial and moves through the mitral valve into the lower left chamber, the left ventricle. So it comes in from the upper left, moves through into the lower left, and then out into the body to feed and oxygenate. This blood comes back around after making its journey through miles of the vascular system, back into the right upper arterial, then down to the right ventricle, then off to the lungs for more oxygen. Your adrenal glands play a major role in how strongly the heart pumps and in its rhythm. The heart is said to be a pump, but actually gets its pressure from the lungs. Okay, so that's pretty interesting fact to know. So let's go over this again real quick, just to make sure we cover the ground. So you have 2 chambers, one on the right, one on the left. The upper chambers are called atrials, and the lower ones are called ventricles. We get fresh blood, fresh oxygenated blood comes from the pulmonary arteries. So the arteries you have in your lungs will, get oxygen, will oxygenate the blood, and then this will go up into the left atrial and move through the mitral valve into the bottom left chamber, and then go into the body to feed and oxygenate, and go, back to your hands or wherever they need to go. And then it makes this full round system. So, yeah, basically picture your whole circulatory system. Picture like all your veins and capillaries being, all the blood that's being pumped through it continuously, and it's just making its rounds until it gets back into the chamber where it can get oxygenated by the lungs and keep doing its thing. Yeah, it doesn't go straight into it, but the lymphatic system plays a big role in this. All right, so next up, the vascular system. Although arteries, capillaries, and veins are not organs or glands, they are a link to every cell in your body, including those that form organs and glands. Their job is to carry vital fuels, building materials to all cells. Your vascular system carries your physical life force, the blood. Blood is used to transport nutrition, hormones, enzymes, oxygen, antioxidants, etc. It works with your lymphatic system. All right, so he does go into it. I know my guy. With your lymphatic system is helping remove cellular and metabolic waste. So this is how you keep your oxygen, keep your blood cells clean. Is they gotta let go of some waste, and all this can dramatically affect your body temperatures. The health of your cells depends upon the health and strength of your vascular system and the blood that flows through it. So you got to keep your blood clean, basically. Vessels. Right here, we got arteries, capillaries, veins. We're going to go into this now. Arteries. These carry fresh oxygenated blood, which is also nutrient rich, from your lungs via the pulmonary arteries to the heart, and then throughout your body to all the cells, tissues, organs, and glands. Capillaries are tiny, minute vessels that connect the smallest arteries, called arterioles, sounds right, arterioles, to the beginnings of the smallest veins, called venules. Oxygen and other elements are exchanged for carbon dioxide, other gases, and metabolic wastes. These are carried through the venous system back to your lungs, kidneys, and colon for elimination. Blood capillary walls consist of only one single layer of squamous cells. So let's see, let's go right here. Oxygen and other elements are now exchanged for carbon dioxide and other metabolic wastes. So not only um are these capillaries allowing, these areas of your body to receive oxygenated blood or oxygenate blood that's already there, but it also exchanges all these wastes. So let's keep going here. Probably keep that. All right, and veins. So, as previously stated, your venous system carries carbon dioxide, cellular waste, and other toxins from the cells and the interstitial areas back to the lungs and other eliminative organs to be eliminated. This is a constant cycle that runs night and day, 365 days a year until death. An acidic diet, excessive glue-like foods like refined starches. So when he says refined starches, glue-like foods, I want you to picture like when you boil down pasta. Say you make ramen noodles and you forget about it, or you make penne or whatever, you forget about it, and you see it. The water's run up a little bit. It's been hot. It's been cooking just like it would in your stomach acid, and it's just fucking. I mean, it's gross. You try to, you can't even pull it apart. It literally becomes like glue, sticks to the bottom of the pan. It's terrible. You don't even. You just go to McDonald's after that. It just ruins your night. And that's what's going on in your whenever you're sending all this shit into your stomach, basically all these pasta breaks down the exact same way inside your stomach. Chemicals, heavy metals, minerals, and lack of calcium utilization from an underactive thyroid all cause damage to this vital system. So yeah, your thyroid gland, we'll get into that more as we get more into this book, but your diet directly affects this, and that's why most people have an underactive thyroid gland. And it's not because you need to take some chemical that you don't even understand, that's been treated and just like completely destroyed. Um, it's not because you have to add more shit to your body. It's because you have to get rid of that stuff. And a lot of times these pills are actually just full of heavy metals. Um, but let's keep going. Let's keep going here. Your vascular walls are sensitive to inflammation from acids that are ingested or that are a byproduct of metabolism. So inflammation happens to protect yourself from acid, if that makes sense. And if your diet is acidic, then you're gonna have a lot of that. If this inflammation goes unchecked by steroids from the adrenal glands, it can cause cholesterol plaquing. This leads to occlusions, aka blockages, that can cause heart attacks, strokes, tissue death, and systemic death. So, yeah, you really need to make sure that that all that inflammation gets checked by having good glands. And really the only way you could do that is teas, fruit, and rebuilding, or else you just have to supplement for your whole life. If that doesn't make sense, feel free to ask questions. Feel free to hit me up on Instagram or whatever. But all right, we're moving on to blood. Blood and chlorophyll are the liquid nectars of life, the life force condensed into nutrients, fuels, building and repairing materials, and the like. Without them, plant, animal, and human life would come to an end. All creatures in nature have some sort of blood or life force that sustains their physical body. It's a nice way to put it. Your blood consists of the formed elements and plasma. These include red blood cells, white blood cells, and platelets. So a lot of basic chemistry we learned in school. The plasma consists of 92% water and 8% of various substances, including nutrients, proteins, ions, gases, metabolic byproducts, etc. So it's mostly water, and then it has all these other things. The chart on the following page will give you an overview of what's in your blood serum. The blood contains two basic types of cells, erythrocytes and leukocytes. I always had a bad time pronouncing those. But yeah, here we go. Blood serum composition. if you can see that. Um, so we got water, 92%, proteins, 8%. It tells you right here what proteins they are. And then the other solutes are just nutrients, ions, gases, waste byproducts, hormones, and neurotransmitters. So there's a lot of the exchanges that you make with other cells when your blood goes through. And then it's this plasma is 4 to 6 million red blood cells. They carry hemoglobin, and this carries oxygen and buffers hydrogen ions. That's maybe that's a little complex, you know. I don't want to go too into all this chemistry, but basically what you need to know is that it's filled up with a few white blood cells that are gonna help you out, you help your immune, make sure everything goes right, and then you have these erythrocytes that are basically just doing the thing. They're oxygenizing stuff. They're cleaning up the byproducts of the other cells, and they're keeping shit moving. And then we got platelets, which are, I guess that's just like, I don't know, like same thing as red blood cells basically, but just helping out. Leukocytes. Wait, let's not skip ahead here. Uh, Erythrocytes are red blood cells. They are red because of their hemoglobin content. The heme part of hemoglobin carries one iron atom, which binds to one oxygen molecule, giving it the red color, kind of like rust. The globin, a protein, bonds to carbon dioxide, and then these red blood cells transport oxygen and carbon dioxide. Combined with this hemoglobin, these cells transport 97% of your systemic oxygen and 92% of your systemic carbon dioxide. So that's a big deal. An enzyme called carbonic anhydrase found in erythrocytes catalyzes carbon dioxide into hydrogen and bicarbonate ions. So again, this is a lot of words, but hydrogen plays a huge role in your body because it mandates alkalinity. You know, pH means potential hydrogen. It means how much can you break something down in, like carbon dioxide, for example, and get hydrogen out of it, and other stuff. And then acidity is basically doesn't have hydrogen in it. It's a lack of hydrogen. It's much less. So this is for transportation purposes, as carbon dioxide lowers the body's pH, making it more acidic, and the lungs convert hydrogen and bicarbonic ions back into carbon dioxide. And carbon dioxide can be exhaled without creating excessive acidosis. So that's why you breathe in oxygen, you breathe out carbon dioxide. You don't breathe out a shit ton of hydrogen. All right, leukocytes are white blood cells. Everybody remembers these, or if you watch Osmosis Jones. These are the immune cells, and they're covered in the immune system section of this chapter, which we will get deeply into. It's exciting stuff. Learn a lot about, like, you know, big pharma and a lot of things. So the four types of leukocytes are neutrophils, lymphocytes, monocytes, aka macrophages, eosinophils, and mast cells. The erythrocytes and the leukocytes are derived from what is called stem cells. Those are the question mark cells. You know, they can be anything cells. Your blood carries many substances that are vital to the health of your body via its cells. It also carries metabolic and cellular waste and byproducts. So just like we were talking about, yeah, same thing. Your body is always seeking to maintain alkalinity, a good balance of alkaline and acid, where acid doesn't take over, and alkalinity, you know, doesn't like protect everything, because you know you do have to have your balance. But alkalinity dominates all fluids and tissues except the stomach. Your blood plays a vital role in balancing this process, from breaking down carbon dioxide to supply electrolytes, steroids, etc. One of the best examples of this balancing process is the way the red blood cells, through carbonic anhydrase, first convert cellular and systemic carbon dioxide into bicarbonate ions, and then convert these back to carbon dioxide when these ions reach the lungs. So yeah, that's all part of breathing, but very very beautiful how the body works that way. The fluids of alkaline species, right here you'll say alkaline saliva, alkaline urine. We went through this in the first video. I got it on my channel, and it'll breaks down how like carnivores have acidic saliva, not acidic saliva, but acidic urine and all these other things. But in general, everything has an acidic stomach. Even a cow that eats leaves has a somewhat acidic stomach to start a fermentation process, so you can digest all that stuff. But yeah, as always, the intestines and blood are always going to be alkaline. And the side effects of acidosis, here you'll see a bunch of them right here. I won't name them all, but you can look at these if you want. And that's just protection from acid. All these, that's just protection from acid. Just an acidic diet, and I'm going to learn more about that. Okay, as stated earlier, humans belong to the frugivore species, which is an alkaline species. The chart on the previous page points out where alkaline fluids dominate the human body and the damaging effects of acidosis. When your diet is predominantly acid forming, your hormones become out of balance. Your food then ferments and putrefies instead of properly digesting, and excessive mucus and inflammation is produced. Your blood becomes toxic to your lymphatic and your lymphatic system becomes clogged. This is called disease by many. So let's go back over this just because it's so important. So when your diet is predominantly acid forming, your food ferments and putrefies. So this has a lot to do with mixing foods. So when when you digest a protein, you need acidic digestion. That's why you have an acidic stomach. But whenever you eat vegetables or plant or something, you need alkaline digestion. So it spends most of its time in your intestines. This right here is like what happens when you mix these foods, because one lowers your stomach acid's acidity and one raises it. And so when you mix foods, they neutralize and they ferment and they putrefy, and that's why food smells bad. It's because it's just meat that putrefied. So let's keep going here. We know this. We know this. We just need to go back over it. As always, keep your body alkaline, toxic, free, and clean internally as well as externally. This creates true health and vitality. So if you eat fruit, it's going to keep your body alkaline because that's how it breaks down. If you eat meat, it's going to acidify a lot of things. And like I said, I just push for balance. I'm not saying eat just fruit. It'd be great if you could, but you just aim to add more fruit to your diet. That's all I'm saying. All right, mouth and salivary glands. We're going into module 2.6. This is the initial phases of digestion. So the mouth offers the mechanical teeth and the initial enzyme breakdown of whole food sources into smaller, simpler complexes. The salivary glands secrete amylase, which is an alkaline digestive enzyme for starch and carbohydrate breakdown. This enzyme hydrolyzes starch and glycogen to maltose. So this enzyme hydrolyzes starch and glycogen to maltose. It converts these into something that is easier for your body to break down and then later put into your blood system. And amylase is basically really, really prevalent in like cows and animals that chew cud and eat starchy vegetables. But it is not present at all in a carnivore's mouth because they have no need for amylase because they don't do any alkaline digestion. All right, moving forward, the stomach. The stomach is located between your esophagus and your duodenum. This is the first portion of the small bowel. It is below the diaphragm and to the right of the spleen. A portion of the stomach lies under the liver. Foods enter the upper portion of the stomach through the cardiac sphincter valve and leave through the pyloric sphincter valve. Didn't know what that was called. The wall of the stomach has 4 layers. The inner lining or mucosa contains simple tubular glands that secrete your gastric juices. Some secrete pepsinogen, and others HCl, hydrochloric acid. There are cells that secrete mucus. So this basically is how your body controls the acidity and the pH of your stomach. It'll either add through these valves. Let me actually highlight it right here. Pepsinogen or hydrochloric acid. So this is what will lower or raise the pH of your stomach to prepare it for what it's about to eat, which your mouth is just informed it after starting digestion with amylase. So when we see, smell, or imagine food, this triggers the secretion of gastric juices. The actual presence of food stimulates the production of the hormone gastrin from the stomach, which in turn releases more gastric juice. This is why your mouth waters whenever you see something you really want to eat. This is why this is why you get happy, you almost get tingly whenever you see the waiter come through with your plate. You're so ready, you've been smelling it like your body knows it's ready. And not only is it like excited about eating, but I mean that's just like, those are glandular, you know, glandular signals basically that your body is preparing to eat that food. It's becoming more attracted to you because you're more prepared for it, and your body's releasing all these enzymes for it. All right, so protein digestion begins in the stomach when the HCl converts pepsinogen to pepsin, which then breaks down complex protein structures into smaller structures called peptones. So we're getting a lot of pep, real peppy digestion, these proteins. This is an acidic digestive process. If there isn't any protein in the food consumed, the stomach acts as a temporary holding compartment for carbohydrate and fat digestion. Let's make sure we remember that. If there isn't any protein in the food consumed, the stomach acts as a temporary holding compartment for carbohydrate and fat digestion. These foods start digesting in the mouth with alkaline digestive juices, aka amylase, and if protein is present, then the stomach acids neutralize these enzymes until these foods move into the duodenum, where they are reactivated and added to. So yeah, it's just awesome how your body instantly knows how to signal to the stomach, hey, this is coming. Make sure that you're either going to do a big acidic breakdown. You're either about to tear down this steak and melt it down so you can use it in your blood, versus, oh, this is just some vegetables or some fruit. We're just going to hold it here for a second. It's going to do most of its job in the intestines. All right, here. So the stomach acts like a time release capsule, allowing your food time to digest or be broken down so the body can actually use it properly. The action of your stomach is through nerve and hormonal control. The stomach can absorb mostly alcohol and water, including tinctured herbs and some fruit and vegetable juices. Spiritually speaking, your stomach reflects the solar plexus, which is the center of the nerve field, which feeds the head, mid, and lower extremities of the body. Weakness of the stomach can weaken your whole body, affecting emotions, oxygen demands, consciousness. And before we move to the next page, I just want to keep going over this. The main action of your stomach is through nerve and hormonal control. That's really important to know. Your stomach feeds your brain. Your stomach feeds your nerves. Your stomach feeds everything. And if you feed it, fucking Takis, it'd be doing too hot. You might get a little emotional, or like, if you're really, strong in the mind, you might be able to like, you might be able to live through a lot of shit, but you're not doing yourself any favors, mentally or physically. Headaches or other conditions. So yeah, you gotta be careful. Let's move along. Small intestines. The small intestines make up the first part of the bowel structure. So this is the first part of the entire bowel. Small intestines are smaller in diameter than the colon, but are 4 to 6 times as long. there are 3 distinct sections that make up the small intestines, each having its own job to do. So this is important to know because, I mean, this is where it goes. You know, it goes into your stomach. It either gets held for a while or it gets boiled to shit, and then it comes over here. First up is the duodenum. This is the first section of the small intestine. Is approximately 8 to 11 inches long, so it's about that big. I mean, just never mind. Through the common bile duct, it receives digestive enzymes, alkalizing sodium of bicarbonate from the pancreas. So let's highlight that. So a bile duct, it receives digestive enzymes. So this is how alkaline digestion happens in the intestines. It just gets a lot of good enzymes through here. It's the enzyme um, transport. So it alkalizes sodium of bicarbonate from the pancreas, which is a product of the pancreas, and it alkalizes bile from the liver, which that's liver, needs some help. So this is telling you a little bit how these all work together in harmony, and we're going to go more into how the pancreas works and how the liver works and how bile works later on, so this all makes sense. Just know it gets bile and enzymes. The major portion of this section of the small intestines is primarily digestive and alkalizing. Hormone secretion is also an aspect of the duodenum. Duodenum hormones consist of peptide. This stimulates the release of peptidase to finish the final protein digestion into amino acids. So after your protein's been broken down as far as it can, these super complex tissue molecular structures are broken down until they're finally ready to get the peptide and become amino acids and get into the blood. Secretin. This stimulates the sodium of bicarbonate and bile for alkalization and fat breakdown. So it basically just gets a pH modifier. We got, actually, I don't know how to say this, cholecystokinin. Cholecystokinin stimulates pancreatic enzymes and contracts the gallbladder for bile extraction. So hits up the pancreas. It's like, yo, needs some enzymes, and then hits up the gallbladder. It's like, yo, need some bile, and cholecytokinin. Fuck, that's gonna kill me saying that. Cholecytokinin. It's gonna do that for you. So shout out cholecytokinin. Make sure you wake up in the morning, you're like, yo, thank you, body, for producing some cholecytokinin today, so I can properly hydrolyze my duodenum. Make sure to say that in the morning. All right, some duodenum enzymes are peptidase. The peptide enzymes, the hormones, they go hand in hand. This completes protein breakdown into amino acids, sucralase, maltolase, and lactase, which is only up to H3. For people that, still want to think that we're meant to drink milk, it's only your mom's milk. It's only till 3. There's been some studies about goat milk potentially being a good exchange if the mother's extremely unhealthy and can't lactate, but yeah, only till age 3 can you actually use that to change complex sugars into monosaccharides or simple sugars. So it's all about simplifying shit for your body. It's all about making sure that your body don't have to work too hard. So let's keep that in mind as we move. Wait, this is pancreas. Where are we at? As we move to the second part of the small intestine. All right, so the small intestine walls are made up of circular folds, aka villi, and they're called plicae circularis. They're like hair, basically. Hair folds. The mucosa. No, actually, that's cilia, right? Yeah, the mucosa folds itself into these villi or microvilli to increase absorption surface of the intestines. These appear like ripples or waves that allow the body maximum potential for digesting and absorbing its nutrition. These glands, called libercons, at the base of many of the villi in the duodenum, um, which secrete digestive hormones and enzymes. So shout out to the Leoberkins, which are the glands that are making all these hormones and enzymes come through. So yeah, obviously your intestines have folds so they can like grab shit, absorb it, get that digestive enzymes on it, and then just start, sucking that shit into the capillaries and getting what you need out of it, because once it's at that state, it's good to go. All right, next part of the small intestine is the jejunum. The second portion of the small intestine is approximately 8 feet long. The duodenum and the jejunum make up 2/5 of the small intestine. Digestive enzymes from the duodenum are now acting upon most of the food particles. Absorption of vital nutrients is now taking place as the digestive enzymes break down the food particles to their simplest form. So it's just keep the shit moving. Shout out to the jejunum. All right, now we're moving into the ileum, and this is the third portion, approximately 15 to 30 feet long, and comprises the lower 3/5 of the small intestine. Most of the byproducts of digestion now have become amino acids, monosaccharides, fatty acids, glycerol, vitamins, and minerals. So let's just make sure we got all that. By the time it's nearing the end, nearing, I guess, like the halfway point, it's everything has been converted. All your proteins, your meats, all your fats, everything has been broken down to its base. Not chemicals yet. These are still molecules, but they're very simple. These are now being absorbed or mixed with water to continue on their way out of the colon, out into the colon. The liquid mixture now passes into the first part of the large bowel known as the cecum, which is the first section of the ascending portion. So, it's all tied up in there. All right, let's keep moving. The pancreas is both an endocrine gland and an exocrine gland. It's located in a horizontal position behind the stomach in front of the first and second lumbar vertebrae. Again, that's a lot of words. It's just basically behind the stomach. Yeah, front of, you know what your lumbar is, right? The little part behind your back. Behind your back. The lower part of your back. All right, the head of the pancreas is attached to a duodenum, and the tail of the pancreas reaches to the spleen. That's good to know. Gives you a little more visual. Should we pull up a picture of the damn immune system? The body of the pancreas has many exocrine glands, which have their own ducts, all leading into the main pancreatic duct, which joins the common bile duct. The common bile duct empties into the duodenum, and all through the exocrine gland tissue are masses of cells called islets of Langerhans. These are the endocrine system of the pancreas. All right, let's go through that one more time. So it has a bunch of these glands in the pancreas. We're talking about the pancreas now. They all have their own ducts leading into the main pancreatic duct, which joins the common bile duct and the duodenum. All right. Copy. All right, so this endocrine portion of the pancreas will be discussed along with the entire endocrine gland system covered later in this chapter. Since we're considering digestion right now, we want to examine the endocrine portion of the pancreas, the ducted portion. These glands supply the bulk of the digestive enzymes needed to break down your food. They also supply sodium bicarbonate, which is an alkalizing substance. Let's highlight all this, which is actually pretty badass. Called chyme. So, chyme is like a general word for alkalizing substance. which is necessary to alkalize the stomach's contents. This chyme is full of HCl, aka hydrochloric acid, and pepsin. Sodium bicarbonate and bile from the gallbladder join the duodenum and activate the alkaline digestive enzymes of the pancreas and intestinal wall. So, the gallbladder has a big job in making the connection here. If the stomach contents cannot be alkalized, then proper digestion is halted. Your food then ferments and putrefies, causing excessive gas. You have then lost the nutritional value of your foods. So this just tells you how important glands are, because all of this needs to be communicated. You need to make sure you're getting the stuff when you need, and if you're asking too much, sometimes it gets halted and you just don't get anything out of it. Pancreatic juice and its function. All right, so we're going to talk about the juices that the pancreas can provide to the intestines, mostly, for the most part. We got sodium bicarbonate, alkalizer and enzyme activator. We got trypsinogen, an enzyme that is converted into trypsin in the duodenum. We got chymotrypsinogen. Yeah, chymotrypsinogen, an enzyme that is converted into chymotrypsin in the duodenum. Trypsin and chymotrypsin finish protein digestion, converting peptones to peptides. From here, peptides are broken down from the intestinal wall by protease and amino acids, the building basic blocks of structures. So, yeah, I guess this is good to know. The peptides are broken down. The peptones are converted by the chymotrypsinogen. We got amylase, which is what breaks down, some of these things into simple sugars, some of these complex carbohydrates and sugars in your mouth. And we got the lipase, an enzyme that emulsifies fats into fatty acids and glycerol. This mixture of enzymes, which is pretty big spectrum, it's taking down protein, it's taking down complex carbohydrates, it's taking down fats and in various different forms. This mixture of enzymes and sodium bicarbonate is called the pancreatic juice. Pancreatic juice has a pH of 8.4 to 8.9, which is alkaline. Way more alkaline than your tap water. Pancreatic juice is stimulated by two hormones, secretin and cholecytokinin, which are produced by the duodenal mucosa. So I hope by this point this sentence can make sense to you. If it doesn't, then just rewatch the video. Feel free to ask questions. This pancreatic juice flows through the main pancreatic duct to the common bile duct and then into the duodenum. Pancreatic juice includes sodium bicarbonate and the enzymes trypsinogen, chymotrypsinogen, amylase, and lipase. Your pancreas is one of your vital organs. If it is destroyed by acidosis and harmful chemicals, what destroys the liver also destroys the pancreas. Spiritually speaking, your pancreas is tied to your thought processes and how they manifest. Yeah, I mean, this is heavy, Your pancreas is the only way that you're able to properly digest things. Without your pancreas providing all the bile, all the enzymes, all this other critical breakdown molecules, then you have no chance of digesting anything. You just poop it right out. Nothing achieved. You just basically pass it through on its way. So shout out to your pancreas. Especially when you're eating fruit, your pancreas is doing such a good job. It's flooding your intestines with alkalizing chemicals, and it's getting all the things that it needs from that food, and then it's being properly digested, and it's not causing acidosis, and it's a beautiful thing. It's a beautiful thing. All right, moving on. We're going to cover the liver and then we'll see what else we can get to today, all right? Liver can be compared to a huge chemical factory that supplies a whole city with its functional metabolic needs. It has been said that it would require 500 acres of land to build such a factory. Your liver has so many different functions that researchers still haven't discovered them all. The body is an enigma. Especially if you learn physics, you're like, okay, at a certain point, you're like, most of this makes sense, until you get to the micro level. And then there's biology, which is like, what how are you doing all that? So yeah, it is definitely important to take care of this most precious organ. The liver is the largest organ in your body. It carries on the most functions. It is situated mostly on your right side, beneath your diaphragm, level with the bottom of your sternum. The bottom of the liver is concave and covers your stomach, duodenum, um, hepatic flexure of the colon, right adrenal gland, and the upper portion of the right kidney. So, I mean, I guess it's good to know this. This is just location talk. So the bottom of the liver is concave and covers your stomach. It's kind of good to know that it's like hugging your stomach. Um, the duodenum and the right adrenal gland. So it's sitting right there on the upper portion of the kidney. Just sitting there tight, right in the middle of everything, really. It has 4 lobes and is covered by. Did we come back? It has 4 lobes and is covered by a thick, tough, fibrous membrane called the Glisson's capsule. So shout out Glisson. All your blood vessels and hepatic ducts enter the liver in the hilus. There are many small intrahepatic bile ducts running through the liver, all leading to the main hepatic duct, which joins the cystic duct from the gallbladder, which then forms the common bile duct. This common bile duct then enters the upper portion of your small intestine called the duodenum at the papilla of Vater. This is the main digestive area of the body. So we're going to read that again, don't worry. First, your liver has 4 lobes. All your blood vessels and hepatic ducts. Let me just pull that up for you. Yeah, so hepatic just means anything associated or located near the river, near the liver. So these all join with a cystic duct. What the fuck? It sounds like I'm saying duct, doesn't it? I'm saying duct. Okay. Yeah, I'm sorry. He could have maybe worded this a little bit better, but basically it joins your gallbladder, the duodenum, and some other stuff, and it's all interconnected. The functional part of your liver are the liver lobules, consisting of liver cells, aka hepatocytes, which are permeated by blood capillaries called sinusoids. The sinusoids are lined with Kupffer cells, macrophages, which are the immune cells of the liver. So let's just remember this first part, that the functional part of your liver are the liver lobules, and it's very connected to the blood. All right, the liver has 4 basic tasks. This will be important. These arise from a multitude of functions. The tasks of the liver are storage and distribution. The liver stores various amino acids obtained from digestion and then reconstructs them for essential body proteins. The liver converts excessive glucose into glycogen and then converts the stored glycogen back to glucose when the body needs extra fuel. The liver also stores and distributes various vitamins, vitamin A, D, E, K, and your liver also stores various minerals. So it stores and distributes basically stored fat and vitamins for the most part, and minerals. And I mean everything. It stores everything. Okay, so what are some of the things that it does? What's some of the chemistry behind what it does? So the conversion, synthesis, and the transmutations of the liver. So when it stores glycogen and your blood glucose level drops, it converts the stored fat back into glycogen. If our glycogen reserves are depleted, it will convert other fats, even stored amino acids, into glucose. This shows you that the number one priority of your body is the need for fuels for energy, glucose and fructose. So it's crazy, right? Because um, whenever you need this, it'll turn fat and muscle, or amino acids, into glucose, and your body will get it however it can get it. um when push comes to shove, your body will start eating itself to get energy, aka glucose, fructose, glycogen, any stuff that is easily converted into ATP. So your body, first and foremost, cares about energy. It don't care about storing anything or keeping that fat there or keeping that muscle there. It just cares about having the energy to keep everything running. So let's continue. Liver function, amino acid metabolism. This is the synthesis of non-essential amino acids. This will convert amino acids into glucose if needed. It is not recommended to allow your body to get this far in its energy needs. This forms urea from excessive amino acids and ammonia. You'll see that in your pee and stuff like that. But yeah, you can you can have this if you have too much protein in your diet, and basically it's telling you that it will convert amino acids or even break down protein to get amino acids to get glucose if it's necessary. And this can be actually really good for you on a small scale if you're doing like a fast. But not, you generally don't want, you generally just want to eat like fruit and like snack on it. Carbohydrate metabolism. So liver has various metabolisms. It converts monosaccharides into glucose. So this is just basically other carbs. Excessive glucose is converted and stored as glycogen, vice versa. So you get too much energy, it'll store it as glycogen, and they'll just keep it on deck. It's beautiful. Fat metabolism. Cholesterol is synthesized for new cell growth and steroid production. Lipoproteins, which are transporters of fat, are synthesized. Fatty acids are converted to acyl groups or ketones, which are used for energy. Bile pigments, including bilirubin, are formed from the hemoglobin of old red blood cells. Bile is synthesized for fat emulsifying and alkalizing stomach contents. So it'll use it for energy, it'll use it for alkalizing, it'll use it for creating enzymes. It's pretty fucking awesome, honestly. The liver converts ammonia from excessive protein consumption into urea. This is then excreted by the kidneys. Your liver synthesizes vitamin K and other clotting factors, including prothrombin and fibrinogen. It basically keeps your blood running at all costs. It synthesizes non-essential amino acids for growth and repair functions. So it basically gets those amino acids ready to be used. Cholesterol is synthesized for use in cell membrane walls, steroid production, and for anti-inflammatory processes. So cholesterol, it's really good. It protects your body. Various minerals and elements are transmuted into other elements. For example, silica is transmuted into calcium. Silica, which you would know in real life as like silicon or like rubber like, almost plastic like, can be transformed into calcium, which everyone knows what calcium looks like. It's just white dust. The liver, really good for your bones. The liver also synthesizes albumin and globulin, which are carrier molecules. These are the transporters. Just good shit. Let's keep it moving. Secretion. Your liver produces and secretes approximately 1 liter of bile per day. Bile is a fat emulsifier and an alkalizing agent. Detoxification, the liver's immune cells digest bacteria, viruses, and other pathogens. I don't really believe in that. But within the blood from digestive tract, a healthy liver can metabolize hormones, chemical drugs, and other chemicals to a certain degree. However, our daily ingestion of these substances is more than most livers can cope with. The liver also produces enzymes to help with the above detoxification process. So, if you're out doing questionable things in the evenings and you're wondering how does all this get in my body, how do I stay alive, your liver, as so shout out to your liver. He's actually going into it right here. You can see from the above functions and processes what your liver does and how important it is to keep it healthy. That's why if you overdrink too much, your liver is first thing to go, because your liver is the one that's just fucking saving your life, really, from all the poison. And the only reason you even get to the point where you're feeling a different way is because your body is just so shocked that your liver can't even do its job properly. It's just catching up. Um, so, acidosis, alcohol, toxic drugs, chemicals, all are extremely harmful to your liver. Almost all drugs, especially coal tar products like aspirin, severely destroy tissues. It's your liver. Send it love and be good to it. I love my liver. Do you love your liver? Um, your liver is also tied to your mind in ways that is not yet understood by most people. When the liver is inflamed and impaired, so is your mind. This can create low self-esteem, anger. Remember, your body develops and functions according to how you treat it, so be good to yourself. And yeah, as always, you need to take care of yourself. You need to make sure you're giving yourself the right diet so you can be yourself, Sometimes we all have bad days, that's not you. You might have just had a steak. It's not my fault. I just had a steak today. I got a little aggressive. There's all these studies on how meat causes aggression in other animals, but they don't do it on humans. All right, last but not least, the gallbladder. Gallbladder is a pear-shaped sac that is located on the underside of the right lobe of your liver. So it's like a little holding sac for bile, which is produced in the liver. So as bile is stored in the gallbladder, the body removes water from it, making it concentrated. So your gallbladder is just holding all these enzymes, all this alkalizing stuff, and it's just staying on deck. As bile is needed for digestive purposes, it moves through a 3-inch duct called the cystic duct into the hepatic duct. So now what we just learned is tying right back into itself. We just learned about all these ducts that go on in the liver, all these ducts that go on in the pancreas, and now they're all coming back into play here. Oh, I wish I hadn't done that. Back into play here to help out with everything. So let's keep it moving here. The hepatic duct then empties into the duodenum, the first portion of the small intestine that we went over. Bile is used as an alkalizer, anti-inflammatory, and emulsifier of fats. It works with pancreatic lipase to break down large fat molecules. Bile contains bilirubin, biliverdin, cholesterol, organic and inorganic substances, salts, lecithin, mucin, etc. Cholecystokinin is a hormone from the intestinal wall that causes the gallbladder to contract, releasing bile. Cholecystokinin is triggered by fats entering the small bowel. So, you need a lot of bile to break down large fat molecules. The gallbladder holds that. Your liver produces that bile, and your intestine asks for it whenever it gets something fatty enough where it needs it like that. So that's a good little breakdown for you. Let's read the summary. Shout out Dr. Morse if you're watching this. I urge you to go watch his stuff. He is still doing it. drmorse.tv. drmorses.tv. In summary, the tissues of the alimentary, what the fuck? Alimentary canal, which is called the digestive tract, are formed from several layers of cells. The first layer is called the mucous membrane. It lines all passages and cavities of the body that have contacted with oxygen. This mucous membrane contains epithelial cells, also referred as mucosa, which secrete moisture or mucus to aid in the protection of the function of the respective organs. This is the protection of your organs. We also have the submucosa or basement membrane, then the connective and the smooth muscle tissues. Most of the mucus or the mucosa comes from the Brunner glands, which are located in the submucosa. So, um, this is a big recap right here, but just so you know, the digestive tract is lined with mucus, and mucus plays a very big role. We consume food and drink for the very purpose of obtaining fuels as well as for building and repairing materials. Basically, most elements and compounds are used as energy sources for the body. All foods and drinks must first be broken down from their gross, unusable forms into simplest or nutritional substances so the body can absorb them and use them. This makes perfect sense. Imagine you had a whole tub of glue, how would your body, you wouldn't just poop out the glob of glue, it would go through a long process, same as with your food, they're all treated differently. Cell membrane walls have microscopic pores so that only the simplest of elements can enter. If not, large particles may enter and cause cellular damage. So you want to make sure everything's working well. Physically, however, most byproducts of digestion, if properly broken down into their simplest form, can now be absorbed through the villi into the capillary bed. The blood now acts as a transporter, carrying the nutrients, building blocks, and fuels to the liver, then to the heart, and finally releasing them into the general system for its needs. Byproducts of digestion include amino acids, monosaccharides, fatty acids, glycerols, vitamins, and minerals, etc. So, it's a beautiful thing. These are, the simple parts that you use all over your body. Your blood just sends it all over your body. And all these organs are just working to make sure your blood stays clean, that those cells are able to receive nutrients and able to like give off that waste they're giving off, and that you have a nice alkaline intestine and stuff to for whenever you get some fruit, or you have enough bile for whenever you get some fats and you really need to break them down. And these foods are really complicated, man. We're the only animal that doesn't eat cooked. Every other animal eats raw, even the carnivores. We're the only animal that eats cooked food. And when you cook something, um it just creates a stronger chemical bond. It just creates, literally has chemical reactions and creates new molecules with heavier ionic bonds, electrons and all that stuff that are just fucking neutral. They're not ready to be broken down, hard to break down, complex. But yeah, we're gonna get into that. We're gonna keep getting into that. I hope you learned a lot about digestion today. Please go back and watch the live streams so you can get the full picture. But really, just go watch Dr. Morse. That's the guy. Get it from him. I'm just a transport. I'm just the blood. I'm just transporting the information to you. So yeah, hope you enjoyed my presentation today. Next time we'll be covering the lymphatic system. I love, if you know anything about me, I love the lymphatic system. Hey, lock me up. I love the lymphatic system. So yeah, get excited for that. Next time we'll be covering all that and much more. Hope you're enjoying the streams. I've been trying to do some more fun stuff lately, playing a little bit of games, but we're still covering chronology. We're still covering biochemistry like today, and we're gonna keep it going. Hope you enjoy the videos. Share the videos. I think it's important, or else I wouldn't be doing this. So I appreciate you. Have a good day. eat some fruit, meditate, learn something. But learn it from an old book. Don't learn it from the usual. Dude, make up your own mind. All right, love you. Do I?